Hi, this is Dr. Fox, and let's talk about the submandibular gland's innervation. In this video, we'll talk about the origin, pathway, parasympathetic ganglion, and terminal branch innervation of the submandibular and sublingual glands. So previously in this series, we've discussed the many branches and functions of the facial nerve. As you recall, the facial nerve, or cranial nerve 7, exits the cranial cavity through the internal acoustic meatus. It's joined by the vestibulocochlear nerve on the way into that hiatus. Once into the hiatus, it travels through the facial nerve canal, a long Z-shaped canal, and it gives off several branches. The greater petrosal nerve, the nerve to the stapedius muscle, and the chorda tympani. The nerve then continues on to exit through the stylomastoid foramen, where it's going to serve muscles of the head and especially the muscles of facial expression. Let's take a moment to examine the pathway of chorda tympani and all of its downstream targets. So, chorda tympani is comprised of preganglionic parasympathetic fibers that are heading out to play a role in the innervation of both submandibular and sublingual glands. Chorda tympani fibers are ultimately going to synapse in what's known as the submandibular ganglion. And along the way, it will have hitchhiked with the lingual nerve and continue to hitchhike, or I should say postganglionic fibers will continue to hitchhike with that lingual nerve, which is a sensory branch of V3, or the mandibular division of trigeminal nerve. Chorda tympani is also going to conduct special sensory fibers, that is, taste fibers, back from the anterior 2/3 of the tongue. So let's take a look at this pathway in total, and of course we'll review this at the very end. So within the osseous canal of the facial nerve, within the temporal bone, chorda tympani branches off. Chorda tympani are preganglionic parasympathetic fibers. Tympani is going to traverse the space of the middle ear, as we'll see it, insinuating itself between ossicles. It's then going to exit the skull through a specialized opening known as the petrotympanic fissure, and it's going to join up with the lingual nerve within the infratemporal fossa. It's then that the preganglionic parasympathetic fibers are going to jump from the lingual nerve to the submandibular ganglion. And from there, postganglionic parasympathetic fibers will either directly innervate sublingual glands or follow vasculature to both sublingual and submandibular glands. Let's take a look at this in greater detail. So here is the nucleus of the facial nerve exiting from the brainstem, and it is heading through the osseous canal of the temporal bone there, and chorda tympani jumps off. It's at this point that it will be going through the middle ear, out the petrotympanic fissure, into the infratemporal fossa, and joining up with the lingual nerve, which is a branch of the trigeminal nerve, specifically a branch of the mandibular or V3 division of the trigeminal nerve. Those preganglionic fibers hitchhike along this nerve. They jump off, go to the submandibular ganglion, and that submandibular ganglion is supplying postganglionic fibers to both the submandibular and sublingual glands, as we'll see. So here we are within the middle ear. This is a view of the lateral wall of the middle ear, and I know that because I can see the eardrum, or the tympanic membrane. There's the eustachian tube, or the petrotympanic tube, or I'm sorry, pharyngotympanic tube that heads out to the nasopharynx. That's heading in the anterior direction. And nestled here between two of the ossicles, that's the incus, and that is the malleus there, is the chorda tympani as it traverses that middle ear space. It's quite remarkable to see a nerve moving through the middle ear. So coming out of the middle ear, the chorda tympani is going to exit through a space, and I'm circling it right there. It's this narrow gap, and here it is on the other side, called the petrotympanic fissure. So this whole space here is the mandibular fossa. That is where the articular process of the mandible articulates with the temporal bone to form the temporomandibular joint, or the TMJ. So just posterior to that joint is the petrotympanic fissure. It's very difficult to see on a skull, but look for that TMJ articulation, and look for the very narrow petrotympanic fissure, because it's through there that chorda tympani is going to exit. So here we have the infratemporal fossa. Many of the muscles of mastication have been cut away here. The zygomatic arch has been cut away, and we can see all of this V3 material here. Specifically, there's the lingual nerve, just anterior to the inferior alveolar nerve. Those are two of the big nerves through there, and that's heading down, and it's going into the sublingual space, heading toward the tongue. Lo and behold, over here, because TMJ is up here, over here, just behind that TMJ, there's chorda tympani coming down behind IN and joining with the lingual nerve. That lingual nerve, somatic sensory, branch of V3. So those preganglionic parasympathetic fibers are hitchhiking on their way along the lingual nerve. And what happens is that just below the lingual nerve there is a tiny little ganglion just dangling there. And the preganglionic parasympathetic fibers that are of chorda tympani that are hitchhiking with the lingual nerve jump off of the lingual nerve and go into the submandibular ganglion. From that submandibular ganglion, postganglionic parasympathetic fibers are going to be distributed to the submandibular gland, and you can see the deep part of that gland there, and also will follow vasculature out along to the sublingual gland as well. And you can see there's the sublingual gland kind of nestled there in that sublingual space. So all of those postganglionic fibers follow, either they go directly to the submandibular gland because it's right there, or you could follow vasculature out to the sublingual gland, or some of them will even follow, they'll jump back on the lingual nerve and hitchhike along to the sublingual glands. It's really quite amazing. So let's review the pathway. Facial nerve, cranial nerve 7 enters into the internal acoustic meatus with cranial nerve 8, which is vestibulocochlear. It then enters into the facial canal, that Z-shaped, very long canal. Gives off a couple of branches. The one that we care about is chorda tympani. Those are preganglionic parasympathetic fibers from facial that are destined to make the submandibular and sublingual glands secrete. They traverse the middle ear between ossicles. They then exit the cranium through the petrotympanic fissure, and they jump on a sensory branch of V3 called the lingual nerve within the infratemporal fossa, and they're going to hitchhike with the lingual nerve down to the submandibular ganglion, which hangs from the lingual nerve in that sublingual space. We have postganglionic parasympathetic fibers that leave the submandibular ganglia and head out to both the sublingual and submandibular glands through a number of pathways. Either the fibers just go to the submandibular gland directly because it's right there, or they follow paravascular plexuses, so vasculature, out to submandibular and sublingual gland, or some may even hop back on the lingual nerve on the way out to the sublingual gland. All of those structures are very close to one another. So that leads us to our assessment question of this video, and that is the preganglionic parasympathetic fibers that will synapse in the submandibular ganglion originate from which cranial nerve? Is it facial nerve? Cranial nerve number 7? That sounds pretty good to me. Glossopharyngeal nerve, which is cranial nerve number 9. Well, it's got a lot in the name that suggests that maybe, but no, we know that that isn't true. Is it hypoglossal or cranial nerve 12? Nope, that controls muscles associated with the tongue. Is it oculomotor nerve, which is cranial nerve 3? Nope. Oculomotor nerve controls some of the extrinsic eye muscles, which we'll discuss in the orbit session. Or is it vagus nerve? Cranial nerve 10? No, that's not the case. Vagus nerve doesn't have any targets up in the head, so that can't be. All of its targets are in the neck, thorax, or abdomen. So that leaves us facial nerve, cranial nerve number 7 as the correct answer. This is the final video of this Learning Objective series. I thank you so very much for your time, and I look forward to talking to you in a later video. Take care, everyone. Be well.